A very good evening to everyone who have logged in on today's session. On behalf of the ATL Innovation Mission team, I welcome you all to another exciting session of the ATL Tinkerpreneur. Today's session is on Internet of Things and its applications, for which we have with us Mr. Sebin Seni joining the live. Mr. Sebin is the Nodal Officer of the Innovation and Entrepreneurship Development Cell and a professor at the Sripati Institute of Management and Technology. He is also the Regional Mentor of Change for Kerala region and has been associated with the AIM team for quite some time now. I welcome Mr. Sebin for today's session. Sir, over to you.
Thank you, Naba. So, a very good evening to one and all. I hope that my audio is clear and also my screen is visible. Now I will share my screen. Give me a second. Is my screen visible now? Can you confirm?
Yes, sir, it's visible.
Okay. So once again, very good evening to one and all. I hope the Tinkerpreneurs are safe at home. So probably this will be the second week of your boot camp. In the first week, you would have studied about different digital skills, and all will be. I am pretty sure that everyone will be, all the Tinkerpreneurs will be very much excited in their journey of a Tinkerpreneur. So today we will be discussing about a new technology. We cannot sell it. We cannot tell it as a new technology, but it is getting more and more popularized nowadays. So the technology is Internet of Things. So first of all, I would like to thank ATL Innovation Mission, the entire team, and also Nidhi Ayog for inviting me to this event to give a small talk about this particular technology. And also today I will be discussing about some of the basic concepts of Internet of Things. So these concepts will help all the students to start their journey in the IoT platforms. So today I will be discussing about a brief overview of the history of IoT. I will be discussing about a simple architecture of Internet of Things. Also, I will be telling about the different applications that we have that we can apply this technology. And by the end of the session, I will be showing some of the practical scenarios, like how to start this, start working on Internet of Things, how to work from your place, how to simulate things. So I will just give an overview. So already, so myself, Sebin Sunny, and I have been associating with the ATL Innovation Mission for past 2 to 3 years. I work as a faculty in the Institute of Management and Technology, and also I work as an nodal officer of Kerala Startup Mission in order to facilitate entrepreneurial growth among students. Also, I work with Raspberry Pi Foundation UK in order to foster computer science education among children in rural parts of Kerala. So that's about me. And coming to the term Internet of Things. So almost everyone would have heard about this Internet of Things. The term Internet is very much familiar to one and all, familiar to all of us, because we are using this Internet in our day-to-day life. So if we look back to our past years, you would have experienced the changing nature of the Internet. Earlier days, the speed of the Internet or the browsing speed was very less, like it was only in the range of kbps. Now with the introduction of 4G, 4G long-term vision, 4G, 4G plus, and recently 5G is being tested in many countries. the browsing speed has reached far beyond our expectations. Now we can browse at a speed of more than 100 Mbps. Then of this fast internet, we'll be able to download a movie within 3 or 4 minutes. Earlier days, these things took a lot of time. So in the past 5 years, we have witnessed a lot of change in the in terms of internet. So going to the history. So before I move on to the history, I will just give a glimpse of what this technology is. So there are two terms. One is internet and the other one is things. So basically, we can tell that if we provide each and every objects around us some internet capability, some communication capability, then we can call it as a smart thing or Internet of Things. So it's basically we are allowing all the objects around us to communicate to the internet. So these objects will be providing some data to the internet. We will be visualizing this data. We will be analyzing this data. And based on this visualization and the analysis that we make, we will be controlling some devices. That's the basics of Internet of Things. So let us move on to a brief overview of the history. So the first Internet of Things, the technology was introduced in 1982. So the first concept was like some of the students in Carnegie Mellon University, they have connected a soft drink vending machine to the internet. So what that project did was like the we will be getting a real-time count of the soft drink cans present in that machine. So that's one of the first IoT machines or IoT device or IoT system that was written in some of the journal papers before. And later in 1990, the first official thing was born. So here, without the help of a computer, you can see here is a toaster. Toaster is there. So without the help of a computer, a toaster is connected to the internet, and this toaster is operated remotely with the help of the first Internet of Thing device. And in later 1999, the term Internet of Things was coined. So the term Internet of Things was coined by Kevin Ashton, and he gave a definition like the Internet of Things is before coining this term Internet of Things, they were calling it as a ubiquitous computing future. So what is meant by ubiquitous? Ubiquitous is nothing and around us, senses, sense the humans, and it will make the human lives better. Like the humans don't need to do anything. Everything will be sensed, and based on the requirements, some actuators will be triggered, and the actuators will be performing all the activities. So now let us see what is the present day situation of Internet of Things. So with the birth of Internet of Things technology, uh, our world show a steep rise of devices. Right now, we have more than 50 billion devices. So that's a huge number. And this much amount of devices and the technology world is expecting to have more than 100 billion devices by 2025. So the growth is very fast. The Internet of Things technology is growing at the entire industry is growing at a very faster rate. And very much thankful to the internet development also. So by once the 5G technology is popularized, the number of devices will be increasing more and more. So that's the history about Internet of Things. So now we will move on to the technology. So whenever we discuss about a technology, especially we talk about Internet of Things, we usually start with the architecture. So probably you all know what the term architecture is. So architecture is nothing but how basically a building is built, how the different interior things are arranged. So in the case of Internet of Things also, explain it with the help of an example. The architecture with the help of a simple greenhouse example. So all of you will be knowing about a greenhouse. So why are we using this greenhouse? We will be using this greenhouse concept in order to grow plants. So inside a greenhouse, we will be monitoring the different environment conditions required for plant growth. So we all know for a plant to grow, it should require ambient lighting, it should have enough water, it should have enough oxygen, and also the nutrient part also is very important. Here you can see IoT system is implemented. So we have some devices to censor these parameters. What parameters? The necessary parameters which are required for the good growth of plants. So there should be some ambient lighting conditions. There should be some good moisture levels. The water supply should be there. Good oxygen and other nutrient supply should be there. So all these parameters, um, give me a second. Let me give me a second. Let me try to. Shall I turn off my video so that sometimes my voice will be better?
Yes, yes, sir. Try that.
Okay. So give me one more second. Let me. Is it okay now? Is the audio now coming okay? Is the audio okay? Naba, can you confirm?
A little better, sir.
Okay, okay, okay. What about now? Is there any disturbance in my audio?
Yes, sir. Now you can continue, sir. It's better.
Okay. So this is a simple example of a greenhouse. So if there is any audio disturbance, please let me know. And Naba, just put a message so that I will be able to know. So this is just a simple example of an Internet of Things system. So here we will be monitoring different parameters that are required for plant growth. So I already mentioned about the different parameters. So we will be having some devices to sense the environment, and we technically call these devices as sensors. And in order to and these sensors will be sensing the physical parameters, and the sensors will be outputting some data. So the data need to reach the internet. So whenever the data reach the internet and the data is being analyzed in the over the internet, then we call it as an Internet of Things concept. So the sensors will be transmitting this data. Okay. So the sensors will be transmitting the data communication gateway. Communication gateway is nothing but probably all of you will be using internet nowadays. So how your phone communicates with the internet? So or how your systems, laptop, desktop, these things communicate with the internet. In your house, if you are having a broadband connection or a fiber to the home internet connection, there will be a small device known as modem. It's a short form for modulator, demodulator. So this modem will be acting as a gate, which permits the data from your part to reach the internet, and also the data present in the internet to reach you. So it's like a gate. So here also we require a gateway for the sensor data to be communicated towards the internet. And at the internet, we have a space known as cloud, we usually right now all of you will be familiar with the term cloud computing. So with the help of this cloud or the servers which are virtually set up somewhere away from your home, in that servers we will be storing this data, we will be analyzing this data, and we will be visualizing this data. So with the help of some user interfaces like your desktop, your system, or your mobile phones, you will be visualizing this data. And the cloud, inside the cloud, we will be running some algorithms which can make some decisions. Like, for example, one of your sensors is telling the system that there is no enough water in the greenhouse system. So when this data reaches the cloud acts like a brain. It runs an algorithm to trigger an actuator. In this greenhouse, the actuator will be a simple motor. So the motor will be turned on, or a sprinkler will be turned on by the data provided by the cloud. So the actuator will be triggered, and some water will be sprayed to the plants. So that's a simple scenario. So I will just once again consolidate what all things are present in the Internet of Things system. Usually, whenever consider an Internet of Things system, there will be some kind of sensors which will be sensing the environment. There will be some kind of actuators which will trigger the actuators based on the data received from the internet. And the sensor data will be communicated towards the cloud through a communication gateway. The data reached in the cloud will be analyzed and visualized with the help of a user interface. So these are some of the different uh, different parts of an Internet of Things system. So now let us see each and every part in detail. So the first thing that we discussed is about sensors. So what is sensors? Sensors are some electronic devices. So here you can see different kinds of different types of sensors. So most of you who have visited your ATL labs, you will be familiar with some of these sensors uh, seen in your screen. So what these sensors actually do? These sensors are electronic devices which capture the data. It's not like capturing the data. It will sense its environment, the physical parameters like temperature, humidity, moisture, different types of gases. So all these physical parameters will be sensed by these devices. So here you can see there is a motion sensor. Actually, it's a passive infrared sensor, PIR. So it monitors the motion of humans. So whenever a human passes in front of the sensor, there will be some potential change inside the PIR sensor, and it will immediately send a data to the brain or a controller or a processor. So the controller or processor will understand that something has moved in front of it. Second to that, you can see the soil moisture sensor. So you can see two clamps there. So in that, the resistance is being changed. So whenever there is water or whenever there is moisture content in soil, the resistance of this sensor changes, and based on that, we will be getting an output. So sensors can be classified into two broad categories. One is like some sensors, they are like analog. Analog means you will be familiar with the voltage levels. So the batteries that you use will be of 3.3 volt or 5 volt voltage levels. So these voltage levels, 1 volt, 2 volt, 1.1 volt, 1.2 volt, 1.3 volt. So these sensors, based on the resistance, there are some sensors which provide these voltage levels. Such sensors we called it as analog sensors, or those sensors which provide say continuous value between 0 volt and the VCC provided. We call it as analog sensors. Those sensors which provides digital values. What are digital values? The binaries, ones and zeros. So if any sensors are providing these digital values or binary values, we call them as digital sensors. So the sensors will provide some values in at their output. So these value need to be captured by some controllers or processors. So what these controllers and processors will do, the controllers will be checking this value. So if some analog sensor is used, the controller may not be able to interpret what kind of data is being received, because the controllers and the processors understand only machine language or the digital data. So what we do is that we will convert this analog value to a digital value, and we will provide this digital value to the controllers. So we will see these things when we discuss the embedded platforms. So hope that you are clear with sensors. So sensors are nothing but they are small devices which sense the environmental parameters or the physical parameters around the device. And we talked about actuators. So what is basically actuators? Actuators is nothing but some devices which are performing some action. So for example, I told about, so when the levels go below a certain value, what happens? An algorithm in the cloud will be telling the system, or the cloud will be providing some value to the controllers, like the moisture level is low, or the controller itself will provide a signal to a relay or an output device or a driver circuit, telling that you need to perform an action. So if it's a motor is in the output side, then the motor will trigger to run. The motor will be triggered to on condition. So in our greenhouse case, we need to run a water pump to activate the sprinkler mechanism. So the controller or the cloud part will be providing some signals, and according to that signals, the water pump will be triggered and water will be supplied to the plants. So that's what basically actuators do. Actuators perform some activity based on the control signals provided by the microprocessors or microcontrollers, or even directly by the cloud part. So that's basically what actuators do. So here you can see different types of actuators. There are motors are there, LEDs and bulbs are there. The speaker also is an actuator. Here there is a GSM modem. GSM modem actually it's a controller. There is an embedded controller in it. So based on the data, it will be transmitting and receiving data. Here there is some fan is the buzzers. Buzzers you will be familiar in most of the toys. You would have seen this buzzer thing, the smart plugs, door opener, displays, solenoid valves. So all these different things comes under the group of actuators. So now I think you can visualize these things in your mind. So the simple architecture consists of some sensors which sense the physical parameters, provide the data to some controllers. The controllers in turn with the help controllers will transmit this data through communication gateway towards the internet. So based on the sensor values received, some actuators will be triggered to run. So here we talked about a microprocessor or microcontroller. Usually these microprocessors or microcontroller, we consider them as embedded platforms. So what is embedded means? Embedded is nothing but a platform where we will be having all the peripherals, the ICs, everything will be there in a single platform, and we will be having some embedded softwares in it. So with the help of these devices, we will be able to realize a simple Internet of Things system. So most of you will be familiar with the Raspberry Pi. Raspberry Pi is a microprocessor unit. So what is the basic difference between a microprocessor and a microcontroller? Here Arduino. So what's the basic difference? A microprocessor is similar to the phone that you similar to the laptop, the desktop that you use. It's like a computer. It is capable of processing in real time. Can process data in real time. So that's what we call Raspberry Pi. That's what we call a micro. Pi is realized with a broad.
Is it better now? Is the voice level better now? Naba,
Yes,
can
sir,
you?
yes, sir, it is better now.
Okay. So Raspberry Pi is nothing but it's a microprocessor. So microprocessors are capable of doing real-time data processing and also different types of jobs. Microcontrollers are like your calculators. It is used only for a specific job. We can do only a specific job with the help of a microcontroller. So here you can see an Arduino. The Arduino is equipped with a microcontroller and the IC is Atmega 328. And this Arduino does not have any wireless connectivities. So the wireless connectivity you will be familiar because you will be using Wi-Fi in your house and also using 4G technologies in your mobile phones. And there are several other technologies like Bluetooth, uh, long range communications like LoRaWAN, Sigfox communication. So there are several wireless technologies. And we also use some wired technologies also. So in the case of Internet of Things, we mainly use wireless technologies. And here the Arduino is not having any wireless capabilities. It can communicate only through an Ethernet cable, or it can communicate only through a USB port. So usually we will be providing some additional parts for this Arduino, and usually we call it as shields. We call it as Arduino shields. So the third one, ESP8266, we call it as Node MCU. So Node MCU is capable of, it possesses a microcontroller in it, and also it is having inbuilt Wi-Fi capabilities. So with the help of this inbuilt Wi-Fi capabilities, it can transmit data directly towards the internet through a gateway. Gateway like your modem or the Wi-Fi hotspots in your mobile phones. So these are three different embedded platforms. The first one is the Raspberry Pi, which is basically a microprocessor. The second one is an Arduino, which is a microcontroller. And the third one is a Node MCU, which possesses a microcontroller and also Wi-Fi capabilities in order to transmit the received data. And all these platforms are capable of doing some processing also. For example, if we consider an autonomous driving car. So in that case, we are collecting data from all the parts of the vehicle. And also, while the vehicle is going through the road, we will be collecting the data from the cameras. So we may not get enough time to transmit this data towards the internet and then wait for a response. So in those kind of applications where the response time is very critical, that is, we cannot provide much delay. In that cases, we will provide some computing capabilities for the edge devices. So these devices will be running some algorithms, and based on that algorithms, some decisions will be made. So those are edge computing devices. So in some IoT applications, we see some kind of edge computing devices also. So uh, that's about embedded platforms. So these sensors and actuators will be controlled by the embedded platforms. The embedded platforms, with the help of a gateway, communicate the data sensed by the sensors, and also it provides some control signals to trigger the actuators. So the next part is gateways. So gateway, when I say gateway, just think of a modem, your broadband modem, or the modem that is present in your mobile phones. The device which help you to communicate with the internet. So it's a gateway. So we have several different types of gateways. We have routers is there, ADSL modems are there. And when we talk about Internet of Things, there are some special type of gateways. Like one of the main features of Internet of Things is that it should have, it should work in low energy, and also that is a less amount of energy should be utilized for working of Internet of Things nodes. And also the gateway should be capable of supporting large amount of end nodes. For example, if you consider the case of smart agriculture. So in the case of smart agriculture, if you consider 1 acre of land or 10 acres of land, there will be large number of sensors deployed. So we call these sensors as end devices or nodes. So there will be large number of nodes. So the gateway should be capable of supporting this large number of nodes. If you are considering your household modem, the household modem, you can support a maximum of 16 devices or 32 devices. So it may not be possible to support thousands of end nodes for this kind of modem. So we consider, so Internet of Things is having some different technologies like LoRa. LoRa stands for long range. So these LoRaWAN gateways, they are capable of supporting thousands of nodes. And also the range of these modems are very high. So the gateway shown in the figure, it's a LoRaWAN module. It's an indoor LoRaWAN module. So it can provide a range up to 5 kilometers if the node is placed in a line of sight way of communication. So that's different types of gateways that we have in Internet of Things communication or Internet of Things technology. Is my audio okay? Is there any issue? Naba, can you confirm whether there is any issue
Sir,
with my
a little
audio?
bit louder.
Okay. So that's about gateways. And so in the simpler, so based on the architecture, we have seen the different types of sensors, and also how the data is being transmitted, how the data is being sensed, and also what happens to this sensed data, and what's the use of actuators, and how this sensed data is communicated towards the internet. So next we have internet. We have a special concept on cloud. So most of you would have heard about data analytics, data science, cloud computing. And I think 2 days before, you have heard about machine learning, artificial intelligence. So all these things comes to effect when the sensed data reaches the cloud. Cloud is nothing but a processing medium that we realize in some part of the world. So these are the main cloud computing platforms that we use along with the Internet of Things technology. So here you can see GCP, Google Cloud Platform, and IBM Watson is there, Microsoft Azure, Cisco IoT, ThinkSpeak, ChipStack. So there are lots of cloud providers, cloud service providers are there. So based on the type of application we have, and also based on our convenience, we can select any one of these cloud platforms. So all cloud platforms have their own advantages and their own disadvantages. And we can set up our own server also. We can, with the help of Raspberry Pi, we can set up a physical server. And with this physical server, we will be able to we will be able to analyze the received data. So nowadays, most of the IoT data is being communicated towards a cloud platform. So the cloud platform can be used to store the data, analyze the data, visualize the data, and also run some machine learning algorithms to predict a future event and based on that future event, the IoT system can perform accordingly. So just consider the case of smart city. When we say the term city, you can assume how many sensors will be present in the city. So there will be different types of services, like street lights will be there, parking stations will be there, water and electricity monitoring will be there. So there will be lakhs and lakhs of sensors will be used in such a scenario. So when we consider a single sensor, it will be generating some data. So if we consider lakhs of sensors, it will be generating large amount of data, and we call it as big data. So that's why most of the IoT systems go for a cloud computing or cloud platforms. Because if we set up a physical server, this big amount of data, when we receive a big amount of data, the servers may not be able to perform well. So what all the IoT service providers do is like they will take a cloud platform, and they don't need to invest a large amount initially for the physical platforms. And based on the scale, based on the increasing amount of data, they can scale the cloud services. They need to pay only for the services they are using. So these are some of the different cloud services. So you can easily memorize all these different types of logos here. And the major players include Google Cloud Platform, Amazon Web Services, Microsoft Azure. So that's about the cloud computing platforms. So the next part is the user interfaces. So how we see this data, how a human interprets this data, or how the human can use this data. So these are the different platforms over which we will be analyzing the data. So as I told earlier, the sensors will be sensing the physical parameters around its environment. The sensed data will be processed by a controller or a processor. The sensed, the analyzed data will be transmitted towards a cloud platform through a communication gateway. And with the help of the cloud platform.
So sorry to interrupt you,
Yeah,
but
tell me.
the voice is cracking a lot. So if you could just readjust the.
Give me a second. Let me disconnect and join. So
Yeah.
yeah.
Students, we are just facing some technical issue. We will be back very soon.
Hello, am I audible now? Is the voice okay?
Yes, sir. Yes, sir.
Yeah,
so
actually,
you can
here
start.
we have. Yeah, sorry for the interruptions. Actually, I think it's due to the bad weather here. So sorry for that. Probably there will be some issue with the net also when it is raining heavily. So sorry for that.
Yes.
So let me share my screen. So that's basically analyzed data. So the data analytics may be performed by some microprocessors or the cloud computing platforms. So some of the visualizing tools include Power BI by Microsoft Grafana, So there are so many data visualization tools. So the visualized data, like you will be getting lot of data. Several sensors will be generating lots of data. So you need to know which sensor generated which data. And if you see like, for example, a temperature sensor will be generating some data like 33.1 degree, 33.2 degree, 33.3 degree, 33.4 degree. So you'll be getting lot of data in a single hour. So for a human, it may not be convenient to look onto these decimals and this large amount of data. So instead of looking onto this large amount of data, this will be converted to some convenient diagrams like bar charts, pie charts, line diagrams. So that's basically what we do in data visualizations. So we use some kind of user interfaces. So Power BI is an example provided by Microsoft. So you can visualize this data with the help of your Android application, with the help of an Android application or a web application. And you can use your devices like a desktop, tablet, mobile phones to see these results. And also you can use these user interfaces to control the actuators also. So that's some of the user interface parts that we have. So this is a simple architecture. Now we will move on to the different applications. So before we move on to the different applications, let me play a simple video. Is the video screen visible? Nava, can you confirm?
Yes, yes, sir.
Okay. Naba, is the audio missing?
Yes, sir. The audio.
Okay. So then I will move on to the topic. So this video is just this video is available in your ATL Tinkerpreneurship dashboard. So you can watch it from there. So it is just a mention about different services or different applications that we perform using Internet of Things. So just I will move on to the different applications. So in most of the things that we see around us, IoT is having some applications. So probably most of you would have heard about Industry 4.0. So Industry 4.0, it runs on Internet of Things. Then the medical sector, the autonomous driving vehicles, the agriculture sector, smart cities, smart home, logistics. So in each and everything that you see around, there will be some application of Internet of Things. So let us see what we can do in industry. So in an industry, you all know that there will be several machineries running there, and there will be several types of products being manufactured in an industry. And also these products will be delivered to different customers. The customers will be using these things. Some products like air conditioners, it requires annual maintenance. So here all the things will be automated. So from the production line, in order to produce a product, or in order to manufacture a product, or in order to manufacture an AC, we require some kind of raw materials. So from that point onwards, we need to monitor the amount of raw materials available. If the amount of or the if the store runs out of raw materials, then we need to automatically place the purchase orders, automatically buy things. And the production line. In the production line, there will be several machineries running day and night. All the time it will be running. So we will be deploying some sensors in these machineries. So based on the machine activity, the vibration, the sound, all these things will be sensed. And based on that, we will be running some algorithms, and we will be predicting on what day this machine will require some maintenance. So like that, all the things will be automated with the help of sensors. And once the product is out of the industry, we use some sensors to track the distribution of these sensors. And again, these devices will be always connected to the internet. This will provide, or it will upload some data to the internet based on its usage. And based on the data received, the customer center or the industry will be able to identify at what time this particular product requires a maintenance. So predictive maintenance, analytics, processing, and also the industrial operations, everything can be controlled with the help of this Internet of Things technology. So similar to in the medical sector, most of you will be aware of the wearable devices. So right now you have smart bands. So what these smart bands do, these smart bands will monitor your health, how the health is being monitored. It will check your heartbeat regularly. And also when you walk, there will be some embedded pedometers there. So it will analyze how much work you are doing. So all these things will be communicated towards the storage. Probably all these smart bands will be having some Android applications. So once you log into this Android application, you will be able to see how much calorie you have burned in the past 1 month, past 6 months. Like that, you will be able to monitor your health and what was the peak heartbeat count. And also, is your heart beating slow, or is it beating very fast? Like that, we will be able to know. So there are several devices which can monitor the health in real time. So with time progress, or by 2025, all these things will be more and more available, and we will be able to monitor our health in real time. And a doctor sitting at a remote center will be able to see the entire health history of a patient with the help of this IoT technology. In the case of vehicle, so you are familiar with autonomous driving vehicles. Recently, Google has launched their autonomous driving cars, and also Tesla is having their driverless cars. So what is happening inside these cars? And even the cars that are available in India, some of the cars like MG Hector, and also some of the internet connected cars, many internet connected cars are now coming into the Indian market. So inside these cars, there will be, everything will be controlled with the help of some sensors. The sensors will be monitoring the engine. We usually call it as engine control unit. And also every peripherals, the brake, the wipers, the steerings, the gear levels, the oil levels, the brake fluid levels, everything will be monitored with the help of some sensors. And these sensors communicate all this data to a cloud platform. So with the help of that cloud platform, the owner of the car will be able to monitor. And also at a simple level, probably you would have heard about some GPS systems which will be fixed onto the cars. So the GPS system will help us to see where our car is in real time. We can monitor the movement of our car, and also we will be able to control the car remotely. So when it comes to driverless cars and autonomous cars, the monitoring and also the autonomous driving conditions, that will be enhanced with the help of these IoT systems. And when we move on to the agriculture, so agriculture, as already we discussed, There will be lots of sensors placed in the soil in order to monitor the moisture levels, the temperatures. So all the sensors which are placed in the field, they will provide an overview. And also there are some image processing techniques that are available now. So with the help of some aerial photography or spectro photogrammetry, we will be taking pictures from above. And this using these pictures, we'll be able to identify whether is there any disease affecting our crops. So with the help of these types of technologies, we can reduce human workload. We can automate everything like supplying of nutrients, monitoring the different parts of the field with the help of some aerial photographs. So all these things can be done with the help of this kind of technologies. And in the case of smart city, we know several systems will be integrated there. There will be street lights. There will be some different types of what we say, the traffic control systems will be there. There will be some water supply providers will be there, electricity. So all the each and every systems present in a city will be run with the help of this kind of smart sensors and Internet of Things. So everything will become smart with the help of the technology. And along with this technology, there will be different types of other technologies like machine learning, artificial intelligence. So these things will be controlling, or these things will help the technology to move forward. So the entire scenario will be like the humans don't need to do anything. The sensors and the actuators will be helping or will be effectively replacing the humans. And the data generated will be used to predict some future events. So smart home and logistics also, it's like a similar concept. And in the case of smart homes, most of you will be using some devices like Alexa, Google Home. So with the help of these devices, we will be able to control lightings in our house. And also you can get insights of the devices usage. You can, if you are using a smart light, you can control the smart light with the help of an Alexa. And also the smart light will be communicating towards the cloud, how much hours it has worked, how much energy it has consumed. And also it can provide some insights about its health conditions, like the bulb is having some circuit failures. All these things can be communicated towards the cloud part. So that's about smart home and smart logistics. So smart logistics is nothing but with the help of sensors, we'll be monitoring the we'll be monitoring how a product is reaching its customer. So probably you will be familiar with Flipkart, Amazon, all these e-commerce portals. So they will be monitoring how a product is delivered to the customer. So once the internet IoT technology is provided to these logistics, smart logistics, or supply chain management, then they can monitor each and every package in real time. Right now, we will be receiving some messages from the courier people, like the courier has reached a facility in Bangalore. You will be getting the delivery in 1 or 2 days. Like there will be some inaccurate messages, like you may receive the package in 1 or 2 days. Like that, we will be receiving some messages. But if you are using these technologies, like if you are planting a small sensor there, if we are planting a small GPS tracker there, we will be able to monitor our package or our product in real time. Like if we take our mobile phone and just provide some consumer number or the invoice number, then it will show exactly where the product is. So most of the companies, when they deploy this system through this logistics, they will be able to plan and also to manage the production line and the delivery line very much effectively. So that's a small introduction about the different systems. So now we will see a small demonstration about our a small IoT system using Microsoft Azure platform. And after that, I will show a hardware part. So all of you can see here it's a simulation software or a simulation. It's a web simulator provided by Microsoft. So most of you will be familiar with the green color board. It's a Raspberry Pi microprocessor. And here we have a sensor which simulates the values of temperature and humidity. So here on the right side, you can see the a small program. So in this program, what we do is that we collect the sensor data like humidity and temperature. And this data will be transmitted towards a Microsoft Azure platform. And in Microsoft Azure platform, we will be receiving the data. So in the web simulator part, we'll be telling some details, like we need to connect this particular cloud computing platform. We need to transmit the data towards this Azure platform, Microsoft Azure platform. So there will be an identity for this Microsoft Azure platform. So here you can see one thing. Here there is a, I have created already a Azure platform. And in that Azure platform, I have initiated a IoT hub. So I have given the details of the IoT hub in my program. So once I start running this simulator, it will simulate some temperature and humidity data. This temperature and humidity data will be transmitted towards the cloud computing platform. So the cloud computing platform that we use here is the Microsoft Azure. And similar to the Microsoft Azure, we can use IBM Watson, Google Cloud Computing Platform, Amazon Web Services. So there are several cloud computing platforms which we can use. So in most of this platform, there is a free tier, like the students can use some of these services for free of cost in order to study these things. But when we go commercially, we need to start paying for each and every services that we use. So now let us see the familiarize the this is the Microsoft Azure portal. So here you can see lots of services there. So actually, these cloud computing platforms, they're more commonly used for data visualizations and also processing some like hosting your website. So and also for running some machine learning and artificial intelligence algorithms. So these are some of the common uses of this cloud computing platforms. So the interface now you see in my screen is a Microsoft Azure interface. So there are several around 150 different types of services offered by Microsoft. So IoT Hub is one of the service offered by Microsoft Azure. So with the help of IoT Hub, we can deploy any number of devices. So here, without the help of any physical servers, like if we need to realize a physical service, then we require some Raspberry Pi. I am talking about local servers, and we need to configure the Raspberry Pi as a server, and then we need to configure it to receive the data from different server, different end nodes. So instead of that, I am using a cloud computing portal. With the help of this portal, we'll be able to manage to add lots of devices in a single go. Only thing we need to do is like create a device, specify the uh, device ID, and provide the some credentials like host ID, primary host ID, API key to the program. So once the end node gets connected to the internet, the cloud computing portal will automatically fetch the data from the end devices. And this fetched data will be stored securely in some cloud storage parts. So this is one IoT hub that I have created. So inside the IoT hub, I have created a device. So here you can see one of the IoT device that I have created. So based on the network speed, it may take some time. Here you can see one, I have created one device. So these are the device parameters. So there is a device ID is there in order to identify each and every device. So every devices will be having a unique ID, and we will be using this primary key, secondary key, and a primary connection string to specify the end device. So we will be feeding this value to the end device. So here you can see I have fed this value to the end device. So once the end device, this is our end device, when it gets connected to the internet, we can monitor the values sensed by the devices in this particular portal. So right now I will just show the different values received from the web simulator. So here we have a command line interface. We call it as CLI. So using this command line interface, we will be able to see what type of data is being received. So I will just show. So LoRa CMAT is the CMAT1 is the name of my end IoT hub. So let me show you the type of data received from the end nodes. So now my system is the cloud computing part is warming up to receive messages. So now you can see a message received from the web simulator. Here the payload consists of the type of message, the device ID, and the temperature generated by the device and the humidity provided by the device. So I think I hope that you can see these different values here. So like that, we will be able to receive data from the physical device also. Inside the physical device, we will be telling like these are the different uh, keys of the platform. And with the keys, once you get connected to the internet, you need to provide data to the cloud computing platform. So once we configure the device like that, we'll be able to fetch the values from there. So once we get the values, we'll be able to store these values, and according to our application, we can analyze these values. So with the help of some user interface devices, we'll be able to visualize and also to analyze these things. So the next, probably those who have worked with Internet of Things, or they would have heard about ThinkSpeak also. So ThinkSpeak is an open source platform developed by MathWork Laboratory. MATLAB, some of you may have heard about MATLAB. So here I will show just a physical device connected to it. So you can create an account here. There is no payment or anything is there. Only for commercial license, you need to provide some payment. For educational, it's so you can use this ThinkSpeak. So this ThinkSpeak is very much simple. You can initiate some channels here. So just go to channels and create one channel. So once you create the channel, you will be getting some parameters, just like the parameters that I have shown in Microsoft Azure. You will be getting some API keys. So just call these API keys in your physical devices. Now I will show you one physical device. Some of you may have seen this physical device before. So I will turn on my camera now. Hope that you will be able to see a Node MCU device. And also the Node MCU is powered by an ESP8266 platform. So I will just show an ESP8266 to you. So this is our ESP8266. So earlier I told, when we discussed about the embedded platforms, I told that the Arduino is not capable of connecting to the internet because it does not have any wireless interfaces. So usually we go for an ESP8266 module to interface with the Arduino to get connected to the internet. For the Raspberry Pi, it have inbuilt Wi-Fi modules. It can wirelessly connect to the internet. For Arduino, we can use ESP8266 based chips. So this one is your Node MCU embedded platform. This has an inbuilt Wi-Fi module. So with the inbuilt Wi-Fi capabilities, it can directly communicate with the internet. The only thing you need to specify is the details of your modem, what is the SSID of your Wi-Fi connection, and also the password of your Wi-Fi connection. Once you specify these things, and also the things speak public and private keys to this thing, we can communicate the data received by this module to the ThingSpeak. So here I have a digital humidity and temperature sensor, DHT sensor. So this sensor will monitor, or this sensor will fetch the physical parameters like the temperature, humidity from its surroundings. And this temperature and humidity will be converted to some digital values. And these digital values will be communicated towards the things speak channel. So here I have already created some of the, so inside the channel, right now I am going to connect my node MCU. So once I connect my node MCU, it will search for the Wi-Fi connection, the Wi-Fi connection that I have configured in my node MCU. So once it finds the Wi-Fi connection, it will start communicating. Now you can see the status got changed. The last entry now is like less than a minute ago. So all these different charts, so these different charts represents the temperature received. So here you can see it's a 29.9. So it's received at 1 p.m. So you can see 33 degrees Celsius. It is showing the status like a few seconds ago. So it's another type of visualization. It's like a gauge. So the gauge shows how much amount of temperature is sensed by the sensor. And also here there is a humidity gauge. Now it's showing 82 as the relative humidity. So these are different types of visualization. So the visualization is very much simple. You can add a visualization, go to a channel, just create a channel. So creation of a channel also is very simple. Just I showed you, just click on new channel, just provide some name, and then just select the fields. So in my case, I am using a DHT sensor. So there are two fields. One is the humidity and the other one is the temperature. So I will be creating two fields. So once I create the two fields, just click on save channel and your cloud platform is ready. Then you need to configure your hardware. So in order to configure the hardware, you need to get some values. So this is one write API key, application programmable interface key. So you need to copy this key to the program. So the program is available everywhere. You can just go to any site like Instructables or hackstuff.io. There you will be able to get the program of this thing. Just copy paste this value and you will be able to monitor the sensor values generated by your device. And you can add any much different types of visualization. Here you can see one gauge is there. And also if you need to visualize it as some other form like a bar chart, column, or different types of representation, you can go for that. So ThingSpeak is a good platform for those who start to use Internet of Things technology. And also most of you would have heard about Tinkercad. So Tinkercad is a place where earlier this Tinkercad was providing us some electronic components. electronic components to realize the IoT system available in our Tinkercad. It's an open source platform. It was NodeMCU was available in the Tinkercad project. Still, anyway, we can use some what we say. We can use or we can use Odin or some platforms like that to realize simple projects like sensing the values of a simple sensor, studying about different electronic components. So once the screen comes, you will be able to see, you will be able to run the system. Even if you do not have these components, you can run these systems. So here you can see the different types of basic components is here. So you can go through the different components. Here you can see on the right side what is basically a resistor, what we can do with an LED, what is a push button, what is a potentiometer. So this is a simple circuit which demonstrates the use of an analog sensor. So here, instead of an analog sensor, I am using a potentiometer. You can see a potentiometer here. So once I start, this is basically a potentiometer. Potentiometer is a variable resistor. So the variable resistance based on the based on its control, you can see when I increase, when I turns the dial, you can see the voltage changing. So this is the analog voltage. This analog voltage is provided to the Arduino. So, but the IC, the Atmega 328 IC present in the Arduino cannot read this value 3.4 volt. So this 3.4 volt with the help of an analog to digital converter will be converted to a digital value and then fed to the controller. Then the controller will be able to understand what value is reaching the controller. So you can try experimenting with some of the basic circuits. So inside the Tinkercad, you can go for different types of circuits are available there. Just search for an analog sensor or a digital sensor, or just search for an ultrasound sensor. You will be getting hundreds of completed circuits which you can use. And this one is an example of a digital circuitry. So here I have interfaced an ultrasound sensor. Some of you will be knowing about ultrasound sensor. It works on the principle Doppler effect. It will be transmitting a sound, and based on the uh, sound reflected back, it will be calculating the distance, and based on the calculated distance will be displayed. So I will just run it, and you can see that. So this example of a digital sensor. So here you can see the ultrasound sensor wires are connected to the digital pins. So based on the value, so here you can see I am changing the distance, the obstacle distance in front. So when the obstacle reaches near 150, below 150, you can see the LED glowing and also the buzzer turning on. And the distance will be displayed in the display. So it's a simple experiment to demonstrate the how the digital sensors are. So here it will be providing some, it will be calculating some time, and that time will be used to identify the distance. So it's a simple sensor. But in the case of Tinkercad, we will not be able to transmit the received data towards the internet, because here we don't have a module to realize the internet communication. So that's all about IoT systems. So if you have any doubts or if you have any queries, you can ask me now. So I will try to answer your queries. Naba?
Yes, so we have a couple of questions. The first question that we have is, which is the best cloud platform to use for IoT?
For IoT, as I told earlier, the most widely used platforms are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. So when we compare these three different platforms, all these three different platforms have their positives and negatives. If we look the most widely used one, AWS, Amazon Web Services, will be the most widely used IoT platform.
Right, sir. So the next question is, which is the best sensor for robots? One of the students has.
Okay, so in the case of robot also, we will use multiple type of sensor based on the application. We need to select the sensors. When we think of a humanoid robot and the type of application it is doing, we need to select suitable sensors. Sometimes we will be using some ultrasound sensors for the path detection, obstacle detection, and all those things. So, and also there are some IR kind of sensors which are used for the same purpose. And if you are going for pick and place robots, that time we'll be using some kind of cameras. So based on the application that we are designing a robot, the types of sensors will change. And nowadays we use some different types of camera, and with the help of some image detection, like a lot of algorithms are available in TensorFlow. With the help of that, we'll be using some cameras to and also to perform some activities. So first we need to specify the type of application that we are going to use. And based on the application only, we will be able to select a sensor. For example, talk about IR sensors. So IR sensors, it basically emits an infrared ray, receives an infrared ray, and based on this emission and reception, we will be telling whether there is any obstacle in front. So ordinary IR sensors, they are capable of only detecting an obstacle up to 8 or 10 centimeters. But if we go for some companies like Sharp IR sensors, then we can detect an obstacle at a range of 80 centimeters to 100 centimeters. So there are different types of that are available in our market. There are some local made sensors, and there are some sensors provided by company. So based on the application, you can select some sensors. Texas Instruments also provide a lot of industrial level sensors. So first thing, you need to specify the application, and based on the application requirements, we need to select a sensor.
So the final question that I have is Raspberry Pi better than Arduino?
So as I told earlier, Raspberry Pi platform and Arduino platform, both are entirely different. If you are using a Raspberry Pi, you can do a lot of things than the Arduino can do. For example, you can use the Raspberry Pi as a computer. The entire it will be able to support, or it will be able to support a monitor also. But when we go for Arduino can support some LCD small displays like 16:4 character display, 16:2 character display. So the functionalities of Arduinos are limited. But when we consider a scenario like the application focus on only single thing, like only for plant monitoring, we are using this thing. So for plant monitoring, we can go for Arduino. There is no need to deploy a Raspberry Pi unit, or we don't need to spend 7,000 rupees to design a small device which monitors some physical parameters like temperature or humidity. So instead of using a instead of spending 7,000 rupees, you can buy an Arduino for 300 rupees and deploy that Arduino to monitor the values of MQTT and transmit this value to the cloud platform and visualize these things in your mobile. But if you are using real-time monitoring system, like just I said earlier, like an autonomous driving car, So there we do not have time to transmit the data to the internet. It's a critical application. So for critical applications, it will be better to use processing platforms like Raspberry Pi.
Thank you, sir. That was actually a very wonderful session. To all the students who missed on a few things, you can always come back to our channel and rewatch this video. Maybe for the glitch, due to the network glitches, if you have missed anything, you can always rewatch the video. I would now like to thank you, sir, for joining us today for such an engaging and interesting session. And to all the ATL students, teachers, and mentors, I invite you all to an equally exciting session on digital products at 11 a.m. tomorrow. So thank you so much, sir, for joining us today.
Okay, thank you ATL team for inviting me to this event. And also, I wish all the Tinkerpreneurs a very best success. With these 9 weeks, you will be able to design a wonderful product. And we are expecting at least 1,000 live products to come out from all of you. So wishing all the very best in your Tinkerpreneur journey. Thank you all. Thank you for being here.
Definitely. Thank you, sir. Thank you.